Here we're going to do some more practice on calculating arc length and area of a sector. Now, we have, first thing we need to do is determine what the total circumference is and what the total area is. Now, if you notice based on the picture, that 14 meters is the diameter, measures the diameter. Okay, so, and our formula asks for the radius. Now I know some of you are like, well, wait a minute. You mentioned earlier, or on our MCAS reference sheet, we can use pi times the diameter. And that is true, you absolutely can. Nothing wrong with that. But do make note that to find area, you have to have the radius, not the diameter. Okay, so that was Max, by the way. So I like to just, because you have to have the radius for the area, just, I want you to get into the habit of making sure you understand that the radius is half the diameter. So obviously if I was using just pi times the diameter, it would this would be just pi times 14. Okay. If you're going to use 2 pi r, it's obviously going to be 2 times pi, and the radius is half, so that's 7. So either way, for the circumference, we do get the same answer. So 14 times pi gives me 43.98, which technically I could technically say is 44, and that's meters if I was to round it. Okay. Now, for area, as I mentioned, radius is half, so I can't use 14, I have to use 7. So this is pi times 7 squared. And always do your exponent first, so that's going to be pi times 49. So 49 times pi is equal to 153.93. I'm hesitant to round here because again, this is a 3, so I can't. Whereas this was an 8 rounds up to the 9, which 9 rounds up to 0. So I did round that to 44. So I'm gonna keep this at 153.93 just for accuracy purposes. Okay, so this is total. Okay, this is the total area and the total circumference for the whole circle. Okay. Now, how does that compare with arc AB? Okay, and if you'll notice, AB has an arc length of 80 degrees based on the central angle being 80 degrees. So AB represents 80 degrees of the total 360. Okay, so that's what I have to multiply my total circumference. So remember, arc length is a portion of the circumference. So let me take my total circumference of 44 meters, and I'm going to multiply that times 80 over 360. Put this over 1, multiply straight across. So 44 times 80 is 3,520. And 1 times 360 is 360. So my final answer is going to be 3520 divided by 360, which gives me 9.78 when I round, and that would be meters. Okay. Again, if you want to do 80 divided by 360, that's a repeating decimal as well, 0.22222. So again, for the most accurate answer, it is best to just multiply the 44, or the total circumference, by the fraction for the most accurate answer. So arc AB is 9.78 meters of the total 44 meter circumference. Okay, and I'm going to use the same exact strategy to find the area of the sector AB. So the area represents this portion of the circle created by arc AB, which again represents 80 degrees of the total 360. So I'm going to take 153.93 and multiply it times 80 over 360. Put it over 1, multiply straight across. So I have 153.93 times 80, which gives me 12,314.4. And then 1 times 360 is 360. So when I divide my numerator of 12,314 by 360, I get a total of 34.2 meters squared. And I should have added meters squared up here. Sorry about that. So sector AB, which represents 80 degrees of the total 360 degrees, is equal to 34.2 meters squared of the total 153.93 meters squared. I hope this makes sense. There's nothing tricky about this at all. It's just understanding that the arc length is the fraction of the total circumference, and then area of a sector is the fraction of the total area of the circle based on the length of the radius. Skip the page, sorry. So give these a try. Both of these problems are asking for arc length. So I put the steps in here. First, calculate the total circumference, and then multiply your total circumference by the fraction of the sector or the arc that is represented. Okay, for this first problem, you should have gotten a 5.24. And for example B, you should have gotten 2.36 or 2.4 if you only rounded to 1 decimal point. If you got both of these correct, go ahead and move on to the next. If you didn't get these correct, I will go ahead and go through these with you. So, of course, gotta remember circumference is 2 pi r, or pi times diameter, either one. In this case, we don't need diameter because we're not given diameter, we're given the radius. So my radius is 4. So 2 times pi times 4. So that's 8 pi, 2 times 4 is 8. And then times pi gives me 25.13. So that is the total circumference. So to get just arc CD, I need to take my total circumference and multiply it times the portion of the circle that CD represents, which in this case is 75 degrees of the total 360. So we're going to multiply 25.13 times 75, and I get 1884.75. Remember, I put this over 1, and then I'm going to divide that by 360 to get the 5.2, it's 5.23, but my third decimal in 1,000 places of 5, so they rounded up to 5.24. Okay. Example 2, we have a radius of 3 centimeters. So my total circumference is 2 times pi times 3, which of course is 6 pi. And when I do 6 times pi, I get 18.85. So then to find the length of PQ, I'm going to take my total circumference and multiply it times my angle or arc degree, which is 45 degrees of the total 360. So 18.85 times 45 gives me 848.25, and then I'm going to divide that by 360 to get, and that's how I get 2.35 or 36. Okay. If you're still struggling, make sure that you're hitting the right buttons on the calculator. I know that sounds kind of silly, but calculators are great provided we push the right buttons. So I'm going to guess that it could be just something as simple as that. Also, and you'll always have your reference sheet, so you'll always be given the formulas. So your formula is always where your formula for circumference is always going to be your starting point. The next page which talks about area of a sector. Okay, area of a sector. So this first one here kind of goes through the steps for you. And we've previously done that. This is a little different though, because what it doesn't tell you is what the number of degrees are. So we have Malaya is playing a game where she must track her progress using sectors of a circle and a circular game piece. The game piece has a diameter of 3.5 centimeters and is divided into 6 congruent sectors. Okay, so that is why, and you don't necessarily have to pay attention or use this particular formula setup unless it works for you. But to determine what each angle measure, what the angle measure is for one singular piece, the key here is the 6 congruent sectors. So if I do 360 divided by 6, that will tell me how many degrees each piece is. And 360 divided by 6 does happen to be 60 degrees. So each piece is 60 degrees. So that's where this 60 degrees comes in. That's where they got that from. And it tells us that the diameter is 3.5. Right now that's the diameter. We have to divide the diameter in half to get the radius. So 3.5 divided by 2, that's where that 1.75 comes in. Now this, all the components are here. They just list the fraction, the portion of the piece, what the portion of each individual piece is first. They just list that 60 over 360 before they listed the area of the total circle, which is pi r squared. It doesn't matter. You know, with multiplication, I can do 2 times 3 or I can do 3 times 2. I still get the same answer. So 1.75 squared times pi times 60 over 360 gives me 1.6. So of the total area, the one singular piece is 1.6 centimeters squared. Okay. Maybe that's a little confusing. Let me do this first. Let me write it out first. All right, so area of the circle, pi r squared. By dividing, close that. By dividing the diameter in half, I get the radius. So, okay, so I'm going to do pi times 1.75 squared. Okay, so I'm going to do 1.75 squared first. Always have to do exponents before multiplying. 1.75. We're going to multiply that. I'm going to square that. And we get 3.06. So pi times 3.06. So then I'm going to multiply that times pi, and I get 9.62. Okay, so that's the total area of the circle. So then now I'm going to multiply this times the 60 over 360, because each individual piece, and there's 6 congruent pieces, is equal to 60 degrees. So my 9.62 times 60 gives me 577.2. And remember, this is over 1. So my final step is divide this by 360, and I get 1.60. So that's where this number comes in here. Okay, so the 1.60, and this was in centimeters squared. That is the area of a single piece, where the 9.62 centimeters squared represents the area of the total circle. I hope that's I clarified that a little bit better than I did initially. Okay, so let's take a look at this one here. We've got Hector's playing darts. The diameter of the target zone is 18 inches. Okay, so that's, again, this is the diameter. So first thing I should realize is that I need radius. So I got to cut that in half. So my radius is actually 9. And the board is divided into 20 congruent sectors. Okay, well, then I need to know what the angle is for each sector. So to do that, because they're all congruent, I'm going to do 360 divided by 20. And that gives me 18, okay? So that means each section here is only 18 degrees. So the arc measure of each sector, so that's 18. Oh, this was, sorry, that was for above, the question above. It must have gotten switched around when I was doing some edits. Sorry about that. Okay, so I know each sector is 18 degrees. So let's first find the area of the total dartboard. So if I have a radius of 9, it's going to be pi times 9 squared, or 81 pi, because 9 times 9 is 81. So 81 times pi gives me a total area of 254.5. So the next step is that's the total circle, total dartboard. Now I'm going to multiply this by just the single sector that I want to look at, which is represented by 18 degrees of the total 360 degrees. Put this over 1, multiply straight across. 254.5 times 18 gives me 4,581. And then 1 times 360, of course, is 360. So to get my final answer, I'm going to divide 4,581 divided by 360 to get a total area of the single little sector that's 18 degrees to be 12.73 inches squared. Okay, so the total area of the dartboard is 254 inches squared. And just that single little sector that's 18 degrees is represented by 12.73 inches of the total. And again, I can confirm that I did this correctly by 12.73 divided by 254.5. So if I compare those two, 12.73 divided by 254.5 gives me, is equal to 0.05. Now, the 18 degrees out of the 360, 18 divided by 360 equals 0.05. So this is an accurate representation because the fractions are actually equal. These are two more problems. Again, area of the sector is number 2. This first one here asks for area of the sector. This example 3 asks you to calculate both the arc length and the area of the sector. Pause the video, take a few minutes, and answer those two questions. Okay, for the first example here about the clock. Okay, keep in mind the first thing you need to do is that you have 12 sections of a clock. So you need to do 360 divided by 12 to find out the measure of each degree for each section. So that's going to give me 30 degrees. So then I'm going to calculate the total area. Which is, so again, the diameter is 3 feet. So that means my radius is 1.5. So when you calculate the total area, you're going to get 7.07 feet. Okay. When I multiply this times 30 over 360, you should have gotten approximately 0.959 feet, 0.6. I know it seems kind of small, but that if you got 0.59 or you got 0.6, you're in great shape. Okay. For example 3, it asks you to calculate both the arc length and the area of the sector. Remember, arc length is a portion of the circumference, and area of the sector is a portion of the total area. Okay, now, your final answer for the arc length is 12.04. Your final answer for the arc length, arc length was 12.04. Total circumference was 37.7. So when you multiply that times the 115 over 360, your final answer would be 1204. Now for the area of the sector, still total area was 113.1, and when you multiply that by 115 over 360, you get your final answer of sector PQ as 36.13. Okay, those are your two final answers. If you are still struggling with this concept after all of these examples, please speak to myself or speak to your teacher to get additional help, because clearly you're making a mistake somewhere and we need to figure out where that mistake is.